In this paper, we present a pilot study on using expressive avatars to increase emotion recognition. Virtual avatars are widely used for collaborating in virtual environments. Yet, these avatars often lack expressiveness to determine a state of mind. Here, prior work has demonstrated effective usage of using emotions and animated lip movement through analyzing mere audio tracks of spoken words. The recognition of emotions in a virtual environment can be achieved through voice. By examining the speech signal, conclusions can be drawn from the visual information of the lip movement and mouth opening. A synchronized animation on a speaking avatar creates a realistic lip synchronization of the spoken words. The facial movement of the speaking person creates a specific face image called visime, which is used to classify lip synchronization. Therefore, we created a natural audio dataset consisting of 17 audio files from which we then extracted the underlying emotion and lip movement. The animations of an avatar's facial expression are inquired by two different factors: the visualization of lip movement and the display of emotions on the face of a virtual character, which can both be extracted from the user's voice or an audio track. To investigate both, we conducted a pilot study with 5 participants in a virtual environment to compare the accuracy and confidence when deciding on emotions. Our goal is to compare whether the use of facial animations makes it easier to determine specific emotions in VR. To conduct the study, we developed a prototypical system that displays the extracted visual parameters and then maps them onto a virtual avatar while playing the corresponding audio file. Therefore, we tested the system in 2 conditions. First, while seeing the virtual avatar only, an audio file was played. Second, in addition to the audio file, the extracted facial visual parameters were displayed on the virtual avatar.
Kam 1977 auf den Markt.
Our results suggest the validity of using additional visual parameters in the avatar's face, as it helps to determine emotions. The recognition rate was determined by correctly identifying emotions for each condition. Participants received lower recognition rates for the audio condition than for the audio with visual condition. Our results suggest that complementing a virtual avatar with visual facial parameters helps to determine the emotional state of an avatar. Although this finding does not seem surprising, we wanted to provide preliminary evidence to support further studies. Our results show that based on the accuracy of the emotion recognition, it is more likely for a user to recognize an emotion correctly when the virtual avatar is additionally displayed with a meaningful facial expression and lip synchronization. However, when using false emotions on a corresponding audio track, users tended to misjudge emotions.